All right, hello everyone, and welcome to today's Explainer. I am absolutely thrilled to have you here as we dive into what is really a foundational topic for any future engineer or business leader, and that is quality management. Over the next 10 minutes or so, we're going to unpack exactly what the word quality means in a real-world industrial context. We'll kick things off by defining the concept itself, then we'll map out the actual operational controls used out there on the factory floor, and finally we're going to zoom all the way out to look at the big picture, total quality management, or TQM. It's honestly a fascinating journey. We're going from simply catching mistakes after they happen to building incredibly robust systems where those mistakes literally just can't occur. So let's get right into it.
So, first things first, what exactly is quality? Well, let's look at how the concept has evolved through three really authoritative perspectives. We can start with the International Organization for Standardization, better known as ISO. Now, their focus is strictly on conformance. Essentially, does the product fulfill its baseline technical requirements? But if we move over to the American Society for Quality, the ASQ, they broaden things up a bit. They focus on customer satisfaction. Ask yourself, does this product or service actually satisfy a stated or even an implied need? And finally, we have the legendary quality gurus in the field, folks like Deming, Juron, and Crosby. They elevated quality to a whole philosophy of predictability and fitness for use. So you can see we're moving away from simply checking boxes on a spec sheet to holistically satisfying the customer with dependable, consistent excellence.
Of course, quality isn't just a one-size-fits-all concept, right? We judge physical goods very, very differently than we judge services. Consider David Garvin's 8 dimensions for product quality. Think about buying a brand new smartphone. You really care about its performance, its durability, its features, and maybe its aesthetics. But when we flip over and evaluate the 8 dimensions of service quality, the whole rulebook changes. When you walk into a bank, you aren't looking at durability. Instead, you're evaluating their reliability, responsiveness, courtesy, and convenience. As engineers and managers, you have to know exactly which dimensions your specific customer is actually evaluating.
Now you might be wondering, why does mastering all these dimensions actually matter to the business? Well, the benefits fall into 3 deeply interconnected areas: strategic, operational, and customer impact. And notice how they just feed right into each other. When you achieve operational excellence, meaning you're reducing defects, minimizing scrap, and just improving your overall efficiency, you naturally offer a better product. That automatically boosts your customer impact through higher satisfaction and better brand loyalty. And when your customers are incredibly loyal and your operations are super lean, you hit those strategic outcomes, a massive competitive advantage, and seriously increase profitability. It's just a powerful, continuous feedback loop.
Let's break that financial impact down even further. I want to walk you through this exact step-by-step chain reaction. Step 1. Improve quality leads directly to Step 2. Reduce costs. Why? Because you have less rework, fewer warranty claims, and way less downtime. That naturally pushes us to Step 3. Increase productivity. Because you're actually getting a higher yield of usable products right off the line. This improves your customer satisfaction in Step 4, which ultimately drives Step 5. Increased market share and profitability. And I want you to pay special attention to a famous quote from Philip Crosby. Quality is free. What costs money are the unquality things. The absolute crucial takeaway here is that investing in doing things right the first time, it literally always pays for itself.
Okay, so how do we actually implement this on the ground? Operationally speaking, we are fundamentally trying to move an organization upward, shifting from a passive, reactive approach straight up into a proactive, preventive approach. A reactive approach is basically just waiting around for a mistake to happen and then scrambling to catch it before it ships. A preventative approach, though, that means planning the design, identifying sources of variation, and monitoring performance way beforehand so the mistake is never even made in the first place.
It is so vital to understand that these different layers, inspection, quality control, quality assurance, and total quality management, they are not just isolated departments down the hall from each other. They form a nested, highly dependent ecosystem. You don't just abandon inspection when you adopt TQM. Rather, inspection becomes the granular core of a much larger culturally ingrained system. So let's break down each of these layers, starting right at the center with inspection.
At the very core, the foundation, we have inspection. The purpose here is simple: detecting defects. But it's really important to note that inspection does not add value and it doesn't correct deficiencies. It only finds failures. It happens at 3 main stages: incoming from your suppliers, in process during manufacturing, and outgoing right before shipment. But a critical advancement here is source inspection and what's called poka-yoke. Poka-yoke is a Japanese term for mistake proofing. A brilliant real-world example of this is the McDonald's fry scoop. It's literally designed so that it's virtually impossible to give the wrong portion size. The physical tool itself prevents the error right at the source. That is inspection elevated to its absolute highest form.
Moving one layer out, we hit quality control, or QC. QC provides the operational techniques to make inspection efficient and to aggressively minimize what we call the cost of quality. We generally categorize these into good costs, which are your investments, versus bad costs, which are just sheer losses. So investments include prevention costs, like employee training, and appraisal costs, like lab testing. On the flip side, our losses include internal failure costs. Think of scrapping defective parts right on the factory floor. And then the absolute worst, external failure costs. These are the defects discovered after the customer already has the product, which leads to returned goods, lawsuits, and a totally ruined reputation. QC aims to invest heavily in prevention to completely eliminate those internal and external failures.
Next up, we step out again to quality assurance, or QA. Now think of QA as this official stamp of approval, but it's not a stamp slapped on at the very end of the line. It actually represents the planned, proactive maintenance of desired quality levels. QA involves all the systemic actions, the standard operating procedures, and the audits required to guarantee a product conforms to requirements long before a physical problem even has the chance to occur. Now, students mix up QC and QA all the time, so let's explicitly contrast them right now. This is a vital takeaway for sure. Quality control is product-oriented and reactive. Its whole goal is detecting defects, finding failures before the customer does. Quality assurance, on the other hand, is process-oriented and proactive. Its goal is preventing defects by building quality into the production stages themselves. To put it simply, QC checks the widget, while QA improves the system that actually makes the widget.
Finally, we zoom all the way out to the big picture. Total Quality Management, or TQM. TQM operates as an unbroken organizational ecosystem. It starts way back with your supplier, moves through your internal processes, and goes all the way out to the customer. But the real magic here is the feedback loop, constantly returning fresh data from the customer right back to the supplier. And wrapping around this entire system is management commitment. TQM absolutely cannot happen if the top executives aren't actively driving a culture of continuous improvement.
A massive pioneer of this exact TQM culture was W. Edwards Deming. He introduced 14 points, but let's just focus on his core tenets today. Deming advocated for a radical shift in responsibility. He basically said we have to stop our dependence on mass inspection at the end of the line. Instead, we need to break down barriers between departments, kill the silos. Most importantly, he argued that management has to drive out fear and actually empower employees. If a frontline worker sees a problem, they shouldn't be terrified to stop the assembly line to fix it. Under TQM, quality becomes everybody's job.
Two major pillars of TQM are continuous improvement and Six Sigma. The first is the PDCA cycle: plan, do, check, act. This is the engine of Kaizen, which is the Japanese belief that every single aspect of an operation can be improved daily. The second is Six Sigma. This is an aggressive, statistically driven standard aiming for a near-perfect 99.9997% accuracy. That allows for only 3.4 defects per million opportunities. It's wild. And it's achieved using the DMAIC model: define, measure, analyze, improve, and control.
So how do we actually hit these incredibly high standards? Well, TQM relies on some specific operational tools. Let's start with benchmarking and just-in-time, or JIT. Benchmarking is simply measuring your performance against the absolute best in class, even if they aren't your direct competitors. JIT is producing goods exactly when needed. But what's fascinating about JIT is that by cutting away all your excess inventory, it ruthlessly exposes hidden quality issues. Think of it like draining the water to see the rocks. If you have no backup safety stock, you are forced to solve your manufacturing problems immediately. Another vital part of our TQM toolkit involves the Taguchi concepts. Ganichi Taguchi totally revolutionized quality by shifting us toward target-oriented quality. Previously, manufacturers were thrilled if a part just fell somewhere within acceptable limits. Taguchi introduced the quality loss function. He proved mathematically that financial costs increase exponentially the further a product deviates from the exact target bullseye, even if it is technically still within the acceptable range. The takeaway? Being just barely good enough still costs the business a lot of money. Finally, we have the analytical engine of TQM,
the 7 QC tools. These include fishbone diagrams for finding root causes, Pareto charts to identify the 20% of problems causing 80% of the defects, and control charts to track process stability over time. You know the old saying, you cannot manage what you cannot measure? Well, these 7 tools give engineers the hard data foundation needed to actually execute TQM initiatives on the factory floor.
Let's tie everything we've discussed today together. Notice how the approach and the responsibility evolve as an organization matures. We start with inspection, a reactive approach focused purely on finding defects, handled only by end-of-line inspectors. Then we upgrade to QC, applying analytics to parameters. From there we jump to QA, a proactive, preventative approach managed by QA teams auditing the process. Finally, we achieve total quality management. The approach becomes entirely holistic and cultural. The focus is system-wide continuous improvement, and who is responsible? Everyone, from the suppliers to the everyday employees, all the way up to top management.
And that brings us to the end of our lecture. Thank you so much for your focus today. As undergraduate students stepping out into the world of industrial engineering and management, I want to leave you with one final provocative question to chew on. When you step onto that factory floor or into the boardroom, will you settle for just reacting to mistakes, or will you be the leader who builds a culture where excellence is engineered into the very DNA of the process? The choice and the future of quality is entirely yours. Thanks for joining me on this explainer, and I will catch you in the next session.